So I recently set these questions, which are quite hard chi-squared questions. The actual chi-squared hypothesis tests aren't that difficult. However, it does ask us to go into talking about the contributions, which can be quite difficult. So here we have the Anza College is is interested in the relationship between anxiety levels and the need to succeed in school. A random sample of 400 students took a test that measured anxiety levels and need to succeed in school. The table shows the results. The Anza College wants to know if anxiety level and need to succeed in schools are independent of each other. So for part A, we're actually having to perform our hypothesis test. So for part A, our H0 is going to be there exists no association between need to succeed and anxiety level. And H1 is that there exists an association between need to succeed and anxiety level. So then the next thing that we need to find is our expected values to see if we need to do any pooling. Now, one important thing is that we do not need to include the totals columns. So that means that I'm actually not going to enter in this bottom one here or this one here down the right hand side. It's only going to be these ones here in the middle. So I'm going to go into the stats part of my calculator. I'm going to go into test chi, and for this first bit I'm just going into two-way. So it says my observed is matrix A, my expected is matrix B. That's fine, and this will automatically be set up for you if you haven't messed around with it in your calculator. Then we go to arrow mat and we're putting our information in here. So we have 3 rows and we have 5 columns, and we can just type that over the top and it'll automatically enter it in for us. Again, if you forget which way around it is, just try them one way. If it doesn't look the same as what your table does, then try them the other way. So I'm going to enter in my numbers going across the top because that's the way that the highlighted cell moves when you're entering it into the calculator. So our first value is 35, 42, 53, 15 and 10. Then we have 18, 48, 63, 33, 31. Then we have 4, 5, 11, 15 and 17. Just a quick check that I've entered all those correctly because there are quite a lot of numbers. And then we have to go back. So I'm going to click exit until I'm back to this screen here. Then I'm going to click XE. That gives me my chi-squared value. Now I don't write this down yet. I have to write my expected values down first, as I explained, because I need to see if I have to do any pooling, which is if any of the values are less than 5. And I have to write these values down as well to show the examiner that I did look at them. So we go into arrow mat, and remember that we said we were having the expected values in matrix B. So that's these values here. Just having a quick look. And yes, there is none that are less than 5, so we are fine. So I'm going to write these down. I am going to pause the video just while I write them down because it takes me a little bit of time to write on here. Okay, so I've just copied down the expected values that were in my calculator here, and I've also labelled it expected values so I know what these are when I look back at them later on. So now I can click exit, and now I can write down this information here. So our chi-squared our chi-squared is 48.4, which is our test statistic. Our degrees of freedom is 8, just reading it off the screen here. And then in the question, it doesn't give us a significance level, so we're going to use 5%. Remember to look at the right-hand side, so we're looking down from 0.95 and across from 8, which gives us 15.507 for our critical value. So our critical value is 15.507, and that is on page 20 of the formula booklet. So, because our test statistic is bigger than our critical value, that means that we reject H0 at a 5% significance level. There is sufficient evidence to suggest there exists an association between need to succeed and anxiety level. So that's answered the first part of our question. Remember that you can check this, because if you have a look in your calculator here, we have this p-value. So what this actually means is that we have 0.000000821 probability that this happens by chance, and we're comparing that to 5%, which is 0.05. So it's much rarer, so we would be expecting to reject H0. That's just a way that we can remember it if we forget which way around we're accepting and rejecting with this hypothesis test. So then for B, we're having to find the contributions. Now this one's quite nice because it specifically asks us to find the contributions, but if it's asking us to comment on any link, I strongly suggest writing down the contributions, because usually there are method marks for doing that. So for part B, what we need to do is that we're going to be using test, chi, and then goodness of fit. Now I haven't entered my values yet, I'm just showing you how this comes up. So this reminds us that we're putting our observed values into list 1 and our expected values into list 2. So that means I'm going to delete what I have in my calculator already. And I'm going to put my observed values into list 1 now. The observed values are these ones here that they came in the question originally. And I'm going to enter them in going across. And it's very important that you remember which way you put them in, because you need to put your expected values in the same way. So we're going to have 35, 42, 53, 15, 10, 18, 48, 63, 33, 31, 4, 5, 11, 15 and 17. And again, just give them a quick double check that you have entered them all incorrectly and in the right order. That's very important that you have got to have the order correct, because it's going to compare the two values to each other. So now in the list next to it, I'm going to write my expected values. Now here I wrote them down to 3 significant figures. You could write them down to more than 3 significant figures if you wanted to, and I will do with question 4. But as long as you have a minimum of 3. If you have slightly more significant figures, then your values might be slightly different, but the same ones should be the ones that we end up talking about in part C. So again, because I went across putting in my observed values, now when I'm entering my expected values into list 2, I'm going to work across again. So 24.4, 22.5, 27.5, 45.8, 61.3, 30.4, 28, 7.41, 12.3, 16.5, 8.19, and 7.54. And again, just a quick double check. You should always have the same number of observed and expected values. So if these two here don't line up, then you've already done something wrong. Then a quick check that we've entered everything in correctly, because we are just going to get our values from the calculator, which would mean that it's gone terribly wrong if it goes wrong now. So I've double checked all my values. So like I said, we're going to go into test, chi, goodness of fit, list 1, list 2. Because we've already done the hypothesis test, it's already got the degrees of freedom in there for us. So that's 8. And that centre bit needs to say list 3. So when we click exit, this chi-squared value here should be roughly the same as the chi-squared value as we had already. And you can see here, 48 point, that would round to 4, 48 point, and that's 4 there. Okay, so I have entered it in correctly. When I click exit twice now, these values here are my contributions. So I'm going to make a table that's the same as my expected values table, but this time I'm going to fill it with my contributions. And we need to remember that because when I entered my values into my calculator, I went across, when I'm filling in the table now for my contributions, I am also going to fill it in going across. So we're going to have 7.53, 0.735, 0.293, 3.62, 6.94, 3.28, 0.106, 0.0471, 0.222, 0.321, 1.57, 4.33, 1.83, 5.66, and then 11.9. So those are my contributions. Now, what the contributions actually are is it tells us how much each value has contributed to our test statistic. And the way that it contributes is that it looks at the difference between the observed and the expected, and it looks at the proportional difference of those values. So the bigger the difference between your observed and your expected values, the bigger the contribution is going to be for that value. That also means that when we if we added these contributions together, we would end up with our chi-squared value. So if you end up with massive numbers for your contributions, but your chi-squared is only 48.4, then something has gone wrong, because these numbers will add up to roughly 48.4. Obviously not exactly because of some rounding, but they should add up to about 48.4, and you can test that yourself if you want to. So then for part C, we're trying to comment on a link between the need to succeed in school and the anxiety levels. So for part C, we need to choose the two largest of our contributions, and this is why we need to do it when we're talking about links. So the two biggest values here are the 7.53 and the 11.9. So the 7.53, I then have to compare the two values that are in that position. So that's high and high anxiety level and high need to succeed. So I can see here that this value, my observed value, is bigger than my expected value. So that means that there were more people more pupils than expected had high anxiety when the need to succeed was high. And the other value is this one here, the 11.9, which is in the bottom right hand corner. So then I'm comparing the 17 and the 7.54. So again, more people than expected had low anxiety when the need to succeed was low. And you could write something about that in terms of why that might happen. You could write a sentence saying when it's a high anxiety test or a high need to succeed test, people suffer from higher anxiety because they feel the pressure of the exam, they're worried about what they're going to get, whereas when they're having a low need to succeed test, then the anxiety level isn't going to be there, they're going to feel more relaxed, they're not going to worry about the results that they're going to get. So you could write a little bit of a sentence about that if you wanted to. Have a look at the marks. If it's only worth 2 or 3 marks, don't put that bit in. If it's not, then do put it in. So I just added a comment in there, like I said, when need to succeed is high, pupils worry about outcomes, so may lead to higher anxiety when need to succeed is low. Pupils feel less worried about the outcome and may lead to lower anxiety. Okay, on to question 2. So this time we've got Transit Railroad is interested in the relationship between travel distance and ticket class purchased, sample of 200 passengers, table of results. The railroad wants to know if they're independent. So for part A, we are trying to do our association test. So again, H0 is going to be no association. Between distance travelled and class of ticket. H1 is going to be an association between distance travelled and class of ticket. Whenever you are doing a hypothesis test, your hypothesis should be the first thing that you write down. Make sure that you're getting them in there. So then we're going to go to test chi two-way because that's how we're having to enter it in to do our test. Arrow mat, remember that we are not including our totals. So again, we have one down the bottom and one down the side. It's just these values here in the middle that we're entering. So this time we have 5 rows and 3 columns. Again, if you forget which way around that is, just have a look at the table. This matches this, so it's fine. We're going to enter the values again going across. That's 21, 14, 6, 18, 16, 8, 16, 17, 15, 12, 14, 21, 6, 6, 10. And again, just a quick double check that they do match each other exactly because we're going to get our value from the calculator. Exit, 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 And there we go, we have our information. Do not write this down yet. Remember, we have to look at our expected values to see if any of them are less than 5, to see if we have to do any pooling. So down to map B, none of those are less than 5, so that's fine. I do need to write them down to show the examiner that I did check them. So our expected values, again, I'm just going to pause whilst I write these down. So again, make sure you write these down to at least 3 significant figures. I've just wrote it down exactly how it is there. I've just copied that table to here, put some labels on the side so I can remember where everything lines up with and the examiner can see I've compared it correctly. So then our chi-squared value is 15.9. That is our test statistic. Our degrees of freedom is 8. And again, it doesn't give us a significance level, so we're going to use 5%. So down the side, 5%, so that's down from 0.95 across from 8, which again, it gives us 15.507. And again, look, this p-value here, 0.0434, that's less than 0.05, so we would be expecting to reject H0. So then as our test statistic is bigger than the critical value, we reject H0 at a 5% significance level. There is sufficient evidence to suggest an association between distance travelled and class of ticket. So now for part B, we're trying to comment on the link between them. So again, we're going to have to write down our contributions. This time it doesn't specifically tell us, but in order to make the correct comparisons, we are going to have to write them in. So again, I'm just going to delete what I have in here. And again, I'm going to type it in going across. Observed values first. That's these ones given to us in the question. Oops, sorry, I haven't clicked across. Try that one again, sorry. 21, 14, 6, 18, 16, 8, 16, 17, 15, 12, 14, 21, 6, 6, 10. Quick check that I've entered those in. 10, 10, 10, 6, 6, 21, 14, 12, 15, 17, 16, 8, 16, 18, 6, 14, 21. Then my expected values going to list 2. That's this table here. Again, going across from the top. Sorry. There we go. 15, 13.7, 12.3, 15.3, 14.1, 12.6, 17.5, 16.1, 14.4, 17.2, 15.7, 14.1, 8.03, 7.37 and 6.6. Oops. Again, these line up. That's a good start. Quick double check that you've entered the values in correctly, because we are going to get our contributions now from the calculator. Good, they're all incorrect. So then we'll go to test, chi, this time we go to goodness of fit. List 1, list 2, list 3. Degrees of freedom 8, good. And look, now we've got 15.9 and our chi-squared was 15.9. That's brilliant again. Exit, exit, list 3 is filled in for us. So again, we're just going to make a table here to show that we did find our contributions. Oops. going to have 1, 2, 3, first, second, third, 1 to 1, 1, 101 to 200, 201 to 300, 301 to 400, 401 to 500. So again, filling it in going across, remembering that this is standard form, 0.0065. Trying to make sure that you write them to 3 significant figures as well. So that's going to be 657, 3.23, 0.476, 0.256, 1.68, 0.129, 0.0503, 0.025, 1.572, 0.184, 3.38, oops, 0.513, 0.255, and then 1.75. So again, we need to choose the 2 largest numbers that we have. So the 2 largest values are, sorry, I just noticed the mistake that I'd made. I've put the titles the wrong way around. That was no good of me, was it? So sorry, on this part here, they should be third, second, first, and then same on the contributions as well. So that's third, that's second, that's first, and then same here. I've just wrote those the wrong way around, I do apologise. That's third, that's second, and that's first. So again, we're looking at our 2 largest values, which are the 3.23 and the 3.38. Nothing else is in the 3s or bigger, nope. So those are the 2 that we're going to talk about. So again, in order to actually write our comparison, we now need to look back at the observed and the expected values. So if we have a look at this one first, the 3.23. So we were expecting 12.3 people to travel first class between 1 and 100 miles, but we actually had 6, so we had less than expected. So less than expected people travelled first class for between 1 and 101 miles. And the other one is this one here, the 3.83. So again, if we have a look here, we were expecting 14.1, but we actually had 21, so we had more than expected. So more than expected people travelled first class for between 301 and 400 miles. And again, this might be something to do with the fact that first class is quite expensive, so for short distances might not be worth it. So for short distances, the price of first class may not be worth the extras, whereas for longer journeys and this is talking about 301 to 400 miles, people may be more willing to pay for the amenities. On to question 3. So this time we've got in a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to spend time with disabled senior citizens. The programme recruits among the community college students, 4-year college students and non-students. In the table we have our sample, and again our part A is to perform our chi-squared test. So our H0 is that there's no association between type of volunteer and hours spent volunteering. And our H1 is going to be an association between type of volunteer and hours spent volunteering. So again, we need to put this information into our calculator, and again we are not going to be including those totals. Now the total columns and rows aren't always on there, it just so happens that they are on these questions. So we're going to go to test chi 2-way, arrow mat. This time we've got 3 by 3. And again, just entering the values in, going across. Again, just quickly double check that you have entered all those in correctly. Exit, exit, exit. Don't write this down yet. We have to check our expected values first. Yes, none of them are less than 5, so I can just write this down now. So my expected values. So we have community college, 4-year student, non-student. We have 1 to 3, 4 to 6, yeah, and 7 to 9. So 90.6, 115, 49.2, 103. Again, you can write these to more than 3 significant figures if you want to. Just make sure you've got at least 3 significant figures. So now I can write this information down because I didn't have to do any pooling. So my chi-squared is 13.0, which is the same as my test statistic. My degrees of freedom is 4. Again, it doesn't give us a significance level, so we're going to use 5%. So we're looking down from 0.95 on the right hand side of page 20, across from 4, which gives us 9.488. And again, that p-value 0.011 is less than 0.05, so we are expecting to be rejecting H0 here. So as the test statistic is bigger than the critical value, we reject H0 at a 5% significance level. There is sufficient evidence to suggest an association between type of volunteer and hours spent volunteering. So then for part B, comment on the link between the type of volunteer and the hours spent volunteering. So again, we're going to be writing down our contributions. So again, we're going to have community college, 4-year, non-student, 1 to 3, 4 to 6, 7 to 9. And again, remember that your observed value is going to list 1. Delete what we've already got in there. So our observed values are going to go into list 1. That's the original table that was given to us in the question. So that's 111, 96, 48, 96, 133, 61, 91, 150, 53. Our expected value is going to list 2. Again, going across. Sorry. There we go. 90.6. 115. 49.2. 103. 131. 56. 104, 133, 56.8. Quick double check again that we've entered that incorrectly. Test, Chi, goodness of fit, list 1, list 2, degrees of freedom 4. Like I said, that will automatically change itself if you've done the hypothesis test first. There we go, 12 point. It is a little bit off this time, but that's because of the rounding of my values. I will just quickly double check though. Yep, they all seem right. So then I'm going to write these in my table here, my contribution table. Again, filling it in going across. So we've got 4.59, 3.14, 0.0293, 0.476, 0.0305, 0.446, 1.63, 2.17 and 0.254. So again, we're going to choose the 2 biggest ones to make our comments on. So the 2 biggest ones this time are going to be these 2 values here. Nothing else is 3 or 4. So that means that we are having to have a look at the community college 1 to 3 and the community college 4 to 6. So if we have a look at 1 to 3 to start off with, we were expecting 90.6, but we had 111. So more than expected, or more community or volunteers, sorry. Than expected volunteered for 1 to 3 hours. Again, maybe due to time constraints. And then we're having a look at the 3.14, which is 4 to 6 community college. So we were expecting 115. We had 96, so we had less than expected. So less community college volunteers than expected. Volunteered for 4 to 6 hours. And again, it's probably due to the same reason. Okay, last question. So question 4. This is a big table this time. And again, though, we do have those totals on the bottom and on the top that we are not going to be entering into our calculators. Not this row and not this column here either, because we don't enter the totals. So here we've got the Bureau of Labour Statistics gathers data about employment in the United States. A sample is taken to calculate the number of US citizens working in one of several industry sectors over time. And that's really important that you understand that these values are about how many people are employed somewhere, so that you can make your conclusions. So now it asks us, and this is all one part of the question, there's not an A or a B or anything like that. So we have perform a chi-square test to investigate if there is an association between the employment and industry sector and the year. Comment on the contributions of the employment figures and what this tells us about the employment in the industry sector throughout the years. So actually this is like the other questions, but without it being broken down into part A and B, and it's more likely that this would be the form that we get an exam question in, where it's all just given to us. We have to read it carefully. It says to comment on the contributions. Make sure you're writing those contributions down. It says to talk about how that links to the employment figures. Make sure that you're making those comparisons. Okay, don't get caught out just because it's not written as part A, part B, part C. You need to be picking these bits out by now. Okay, so our H naught is going to be no association between employment in industry sector and year, and H1 is going to be an association between employment in industry sector and year. Again, we're going to type these into our calculator. So test, chi, two-way, arrow mat. This time we have a whopping 1, 2, 3, 4, 5, 6, 7. Yep, 7 by 3. Lovely massive table, and it does take me a little while to type these values in. I am just going to type these values into my calculator and double check I've definitely entered them in correctly. I am going to pause the video while I do that though. Okay, so I've entered all my values there now. You can see I've just copied them over from this into my calculator. So exit, exit, exit. Again, don't write this down straight away. Go into mat, go down one. We need to copy down these expected values. So again, I am just going to pause the video while I write these down, but this is my expected value table. I'm not going to write out the entire headings. Just let me check what I wrote in the work solutions I gave you earlier. So I'm going to have, WS, goods, services, agriculture, S/U, SW/S, and SS/U. Yeah, and I'm going to have 00, 10, and 20. As long as you can see which ones are which, it's fine. I mean, ideally you would write out the whole thing, but because there's quite a lot of them here, I wouldn't expect you to take the time to do that. So I'm just going to pause the video while again I write these values here in this table. Okay, so now I've copied down all my expected values. None of them are less than 5, so I'm not having to do any pooling again. So I'm going to go back. My chi-squared value is 228, which is massive. My test statistic is then 228. My degrees of freedom is 12. And you can see how big this test statistic is because the probability of this happening randomly is 0. So it's exceedingly, definitely unlikely to happen. So again, it doesn't tell us what significance level to use, so we're going to use 5%. So we're looking down from 0.95 and across from 12, which gives us 21.026. Yeah, so then again, our test statistic is bigger than the critical value, we're going to reject H0 at a 5% significance level. There is sufficient evidence to suggest there exists an association between employment in industry sector and year. So it asks us to write about the contributions as well. So again, just quickly going to write myself a contribution table. I'm going to have the same headings going down the side. WS, goods, services, agriculture, SU, WS, SWS, and SSU, 00, 10, 20, and this time these are my contributions. This is why it's so important that you are labelling these tables very clearly, because if you have to come back and look at them, they can get quite confusing about what they actually were talking about. Okay, so back here, deleting what we already have. Delete, delete, delete. Again, typing in our observed values into list 1. I'm just going to type them in going across. I'll enter the first few to show you, but then I'll pause the video and type the rest of them in. Sorry about that. So we have 13,243, 13044, 15018, 2457. I'll just keep going. I apologise that this is going to be longer than I expected. 786 11 2 7 3 3 3 0 6 8 240 214 201 931 894 972 14 11 11 196 144 152. Again, quickly double check that you have entered those in correctly. This is very important. I'm not skipping it even on these longer questions, because if you've entered one of these values in incorrectly, everything is going to go wrong. So it's very important that you do double check that you have entered them in correctly. Now I'm going to do the same for my expected values from down here. So 13293, 13046, 14965, 1988, 1951, 2238, 11304, 11095, 12726, 211 207, 237 900, 883 1013, 11.6, 11.4, 13, 158, 155, 178. And again, you can see these two finish at the same spot. Double check that you have entered them all in correctly. Lost track of where I was up to then. Yeah. Okay, so then we go to test, Chi, goodness of fit, list 1, list 2, and again you can see that the degrees of freedom was already been filled in for us. 228, brilliant. There we go, and our contributions are filled in for us there. So then just copying them down into our table. So 0.188, 0.00307, 0.188, 111, 16.6, 37.1, 23.7, 2.86, 9.19, 3.99, 0.237, 5.47, 1.07, 0.137, 1.66, 0.497, 0.0140, 0.308, 9.14, 0.781, and 3.780 is going to end up rounding to, sorry.